Hello students. So in this video lecture, we'll be talking about modular arithmetic. Let's begin with a question that in your knowledge, is 2 plus 2 always equal to 4 or it can be some other thing? Well, in most of the maths that we know, 2 plus 2 is always 4, but it's not always the case. 2 plus 2 can be a different number. Let's see how. For example, you talk to a friend 8, 9 o'clock, and that friend tells you that he'll see you after exact 37 hours. Then probably what time it will be when you both would meet. So if you calculate, give it a time, and you calculate it that what time it will be after 37 hours when you count it from 9, so that would be exact 10 o'clock. The similar way, if you want to calculate that what would be a time if someone says that he'll see you after 12 hours and the current time is 6 o'clock, so what will be the time when you both will meet each other? That would be exactly 6 o'clock when you both would see each other. So how does this thing work? It works under the concept that we call clock arithmetic, in which the 12 is just assumed as 0, like we do in the ordinary clocks that we have. We always start our time and our clock looks like 12 here and 3 here, 6 here and 9 here. So whatever time it is, our day passes around of this clock, and once we enter this point, the 12 o'clock, it starts from 0, then it gets to 1 o'clock, 2 o'clock, 3 o'clock, and so on so forth. So every time it completes the round of 12 clocks, 12 hours, it gets again to 0 and it starts again. So in the previous case, when we were writing like 9 plus 37 equals to 10, so it was simply because we can break 37 into parts like 12 plus 12 plus 12, and keeping every 12 equal to 0, this would add up to 1. So we would say that 37 is equals to 1 on the basis of clock arithmetic. And why is it so? Because in clock arithmetic, 12 is simply equal to 0. The similar way, you can check any number. For example, if I want you to calculate that what would be the value of 4 times 7 plus 20, which is like 48. So if I ask you that what would be the value of 48 if you calculate it on clock arithmetic, so you would simply do that. 48 can be written as like 12 plus 12 plus 12 plus 12, or you may say 4 times 12. So if 12 is equal to 0 on clock arithmetic, so 4 times 12 would exactly be 0. So you would say that under clock arithmetic, 48 is nothing but equal to 0. But as in the case of the 12, we are well familiar with it. We are doing it since childhood, that whenever the handle of the clock gets to the 12, we start it counting again from 1. What would be the case if our clock looked like the one on your screen? Like it had only 7 points, and after 7, it started from 1. So how would our calculations have been? So they may have been like this, that if I added 4 plus 6, that is 10 in normal times, but in the crazy clock that we just saw, it would have been 3. Like if I was here at 6 and someone said that, okay, I'll see you after 4 hours. So the next travel in terms of time would have been like, this is 1 hour. After 2 hours, I would have been here. After 3 hours, I would have been here. And after 4 hours, I would be here. So it becomes like 6 plus 4 is equals to 3. Something very strange. Why is this so? Because I'm using a clock that has only 7 points. So in this clock, 7 is equal to 0. Once I get to 7, my counting, my time starts again from 0. And after 7, I get to 1 and so on. So if this is like 4 plus 6, it is actually 10, and I can write 10 to be equal to 7 plus 3, but 7 is simply 0, so 10 would give me the result which is equivalent to 3 using this clock arithmetic which has a cycle of 7. So the similar can be the case when I use a clock that has like a cycle of 9 or any other number. But see, have we ever observed a cycle that completes in 7 numbers? Like after 7, it starts from 0. Have we ever observed around us where do we use this type of clock? Where do we use this type of arithmetic which contains 7 digits and after 7, it starts from 0 again? Yes, we keep seeing that whenever we talk about the number of days in a week. So if someone asked me that, okay, today is, for example, Sunday, and someone said that I'll see you after some 20 days. So now I'm thinking that what day it would be after 20 days. But the simple thing that I would do is I'll say that, okay, today is Sunday. 20 days are simply like 7 days plus 7 days, that is 14, and then 6 days. So I'll just ignore that 7 days because I know that after this 7 day, I'm again on Sunday. After this 7 day, I'm again on Sunday. So this 7 days is simply equal to 0, like I'm on the same day, Sunday. So I'll simply count 6 more days. I'll not be counting all the 20 days that, okay, after Sunday, I'll count Monday, Tuesday, Wednesday, Thursday, Friday, and so on up to 20 days. No, I would simply count 6 more days. So that would be Sunday plus 6 days, and that would be probably Saturday. So I'll say that Sunday plus 20 days, the person when would come to see me would come on Saturday. So this kind of relationship that we simply just talked about is called a relationship of equivalence. We say that under a certain clock, under a certain arithmetics, two numbers are equivalent to each other. Like we said that 20 is equivalent to 6 when you are using an arithmetic, a cyclic arithmetic of 7. We said that like here we said 37 is equivalent to 1 when you were using a cyclic arithmetic of 12. So that cyclic arithmetic is called modular arithmetic. We say that here I would say that 37 is equivalent to 1 under modular arithmetic of 12. So if I'm using the mod 12, 37 would be equal to 1. Making it more simple, we are simply saying that if you divide 37 by 12, you will always get remainder equal to 1. If I'm saying here that 12 is simply equal to 0, it's on mod 12. So I'm simply saying that when you divide 12 by 12, the remainder is 0. So in modular form, I would say that 12 is equivalent to 0 under mod 12, right? So if I ask you that is 13 plus 25 equal to 2, you would definitely say no, it's not. But if we look it on the clock of 9, or simply say with the help of mod 9, it is 2. How is it 2? I can write 13 plus 25 as 13 to be 9 plus 4 and 25 to be 9 plus 9 plus 7. So on the clock of 9 or on mod 9, 9 has 0 remainder, so 9 would be equal to 0 under mod 9. Substituting it to be 0, the simplification of the calculation would give me 2. So the actual way of writing it would be that I'll say 13 plus 25 is equivalent to 2 under mod 9. Now this writing mod 9 would always remind me that 2 is the remainder of 13 plus 25 when this sum was divided with 9. That's the simple concept of modular arithmetic. Now you would simply solve these sort of questions, that what will be the remainder if you divide 928 with 9, or simply saying 928 is equivalent to what under mod 9, and the similar is for the rest of the numbers. Now once we are familiar with modular arithmetic and we know how to calculate the equivalence of one number with respect to another number under certain mod, the most important question is that how is this thing useful? Why are we learning this? What's the use of this thing? So the first use that we often see of modular arithmetic is that to check whether the data that we have is entered in the proper order or not, to verify that it does not have any errors. So on almost all of the products that we purchase from market, there is a UPC code at the back of that product, which is like universal product code. So that code always has some 12 digits, and the digits are in the form like the first 6 digits have the information which shows about the company details. The next 5 digits show the item details, like the product details, that what that product actually is. The last digit of that UPC is always a check digit, which verifies that all these 11 digits are put in the proper order. They are not like misordered, they are not entered wrongly. So this UPC is always like following a pattern and using some modular arithmetic. We'll just simply go and see that how does it work. So the procedure for this UPC is like this. There are total 12 digits in any barcode, which is like the UPC code. We first take the 11 digits and line them up. We name them, for example, the first digit to be D1, the second digit to be D2, and so on up to D11. Because there are 11 digits, we are leaving the 12th digit as to be the check digit. Then we combine all those 11 digits in a very unusual format, which is we multiply every second number with 3, leaving the first number as it is, and then add up all those numbers. The procedure is like this. We have lined up 11 numbers as D1, D2, D3 up to D11. So we multiply the first digit D1 with 3, plus keep the second digit as it is. We multiply the third digit with 3, keep the fourth digit as it is, and do the same procedure up to D11. Once we are done with this sum, we add this all, and since we don't know what the check digit is, we assume that okay, the check digit is C, for example, and we add the whole sum to C and calculate its mod on 10 to see that what should be the value of C. We want that sum should equal to 0 under mod 10. If this is not making sense, let's see a practical example. On the right hand side of this screen, there is a UPC, which is like 0360002851009. So 9 is the 12th digit, which we would refer to be as a check digit. Now the procedure is to multiply first digit with 3, second as it is, third digit with 3, fourth as it is, and so on. We are not using 9 here, and instead of 9 we have taken C. That C can be our check digit. Now when we performed all this multiplication and then added everything, it got to be 51. So we have 51 plus some check digit, and we want that this sum should be equal to 0 on mod 10. Now we need any number from 0 to 9 which can make 51 to be evenly divisible by 10. We need any such number which can make 51 to be divisible by 10 and give us a 0 remainder. So that number can possibly be 9 only, because if I add 51 and 9, that would give me 60, and I know that 60 divided by 10 would give me 0 as remainder. So I would say that 60 is equivalent to 0 under mod 10. So by this calculation, we could verify that okay, 9 is the rightly placed check digit on this barcode. The second thing is that the bank checks has some routing number on one corner of them. And that routing number also has certain information stored in it, like the first four digits give the Federal Reserve symbol, the next four digits give the financial institution details, and the last digit is always the checking number. So how does this mechanism work? It has a bit different format than the UPC format. The UPC format was like multiplying every other number with 3, but the bank routing number does not have that format. It has the format that we multiply the first digit with 3, then we multiply the second digit by 7 and third digit by 1. The similar procedure goes on that the fourth digit is multiplied with 3, the fifth with 7, the sixth with 1, and the procedure repeats. So whenever we multiply the whole number in this format and the sum gets evenly divisible by 10, or the sum like 160 is equivalent to 0 under mod 10, we say that the routing number is in the correct form. Otherwise, it is not. So, for example, if we have uh, a routing number that is like 2118729 and some missing number, and we want to check that whether this is a correct, whether what should be the check digit which makes this number to be a correct routing number. So the procedure was that multiply the first number by 3, the second number by 7, and the third number by 1, and do the same procedure. So if I do it here, that would be the first number is 2. If I multiply 2 with 3, this would be 6. Then the second number is 1. If I multiply it with 7, it would be 7 plus the third number is 1. If I multiply it with 1, it would be 1. Doing the same procedure, I will have 24, then 49, then 2, then 27, then 28, and then I have this unknown number which I will call C. Now I would need that this whole sum should be equivalent to 0 under mod 10. So if I add up these all numbers, I don't know what the sum would be. So the sum of these all numbers happens to be 144. So I have 144 plus some check digit, and I expect this to be equivalent to 0 under mod 10. Now what number makes 144 to be divisible by 10 exactly? So it should be 6, because 144 plus 6 would make it 150, and when I divide 150 by 10, the remainder is 0. So I can say that 150 is equivalent to 0 under mod 10. Now let's see if the correct number is what. Oh yes, so this was from some Williamstone Saving Bank, and its routing number has 6 as the check digit. So this was the simple use of modular arithmetic in order to verify that whether the information that is stored on some important places is in the correct order or not.